All right, so this next unit is going to be a combination of things from chapters 4 and 5, and it's all going to be about mathematical models of some sort. So we're going to start off here by talking about a relation. So a relation is just a set of ordered pairs. So you have some x value, which is a number in your domain, that you're going to plug into some kind of equation of some sort, and you get a y value. And the y value is your set of or the range, I'm sorry, is the set of your y values. The independent variable is your x. The dependent variable is your y. Your y value depends on what you plug in for x. So we have a relation defined by the rule, and rule is just another word for equation. Y equals x plus 2, where x is an element of the set 0, 1, 2, 3, and 4. So to determine the range of the relation, I'm just going to plug in 0, 1, 2, 3, and 4 into this equation. So when I plug in 0, I end up with 2. When I plug in 1, 3. When I plug in 2, 4, 5, and then 6. So this would be the range. Put those little curly brackets around it to show that it's a set of numbers. Now express the relation as a set of ordered pairs. That would be just now giving them, I plugged in 0 to get 2. I plugged in 1 to get 3. I plugged in 2 to get 4. 3 to get 5. And 4 to get 6. Okay. And that's a way of showing that all those numbers are connected by, again, putting them in the kind of curly brackets there. Okay. Next, looking at domain and range from a graph. Now, if they give you a set of points, like let's say that they gave you this set of points, and they ask you what is the domain, well, it's all the x values, 0, 1, 2, 3, 4. What are the y values? What's the range? You list out the y values. Doing it from a graph is a little bit different. So looking at the first graph there, I'm going to kind of enlarge this. Try to enlarge, whoa, there you go. Just so you can see the graphs a little bit better. So the first graph here, this graph continues on in both directions. So I'm looking for what x values does this graph cover? Well, this is going to continue going up, up, up. Now mine kind of slanted, but it's going up just super slow, but eventually it's going to hit every single x value. And same thing on the other side. So the domain is all real numbers, or negative infinity to infinity. The range is the same thing. This graph's going to go up, 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 down, down, down. So again, you list that there however you want to. Now, for B, the domain is exactly the same thing. It's going to get there much slower, but this graph is going to continue going up. Eventually, it will hit every x value. Same thing on both sides. So all real numbers or that. Now, the range, though, I don't have any y's down here. I'm never going to have any y's down there, but these y's will keep going up. So my range is going to be starting at 0, going up. You could also say y is greater than or equal to 0. Now, if you're thinking about, well, it's just all the positives, it is a thing to write this, all real numbers with a plus on it, but that would not include 0, because 0 is not positive, and it's also not negative. So it's not the negative reals, but it's 0 and the positive reals. All right, the next one, my x's don't go past 4. So this one is going to have a cap, but it does continue to have all of these x's. So my domain is going to be from negative infinity until 4. Now, I know that we've had debate about whether you put parentheses and brackets sometimes with our intervals. This one, though, it needs to have a bracket on the 4, because if you put a parenthesis on the 4, that means it gets really close to 4, but it's not actually 4. The bracket means it is actually 4. But remember, infinities, you cannot get to infinity, so don't put brackets on infinity. Okay. Now the range for the y values, I don't have any y's down here, but I have all these y's here, including 0. So we're going to be 0 to infinity. Trying to move it over here instead of that. Here we go. All right, so domain for D, the domain are the x values. So here is a boundary on my x's. I don't have any x's that go past that, and I don't have any x's that go past this line. Now, to put that into words here, my lowest x value is a -4. The highest x value is almost 3, but because there's an open circle there, you put a parenthesis on it. Now, you don't want to say 2 because this is one of your x values. I don't know exactly what number that is, but I know that it's really close to 3. Range, now we're looking at the y's. So this is the lowest y, this is the highest y. Close to -5, but not quite. Close to +5, but not quite. Okay, now the last one, we have to do this one in pieces. This is 2 graphs that go together. So, like concentrating just on this half, let's do that first. The x values for that part, for the domain, that my lowest x is a -1, and then I just continue to have all the x's past that. So we have -1 to infinity. Y values, okay, that lowest y value that I have there, I'm going up from there, so that's going to be a y value of 3 to infinity. Okay. Now on the other side, which is really what I should have started off with first, we've got to do that one now. So the domain for that, my lowest x value, and going to the left, so it's not quite -1, but it's close to -1. Negative infinity to close to -1. Okay. The range, okay, my lowest, or my highest actually in this case, my highest y value is almost -2, and then I go to negative infinity from there. Now when you give these, we should technically put the U symbol in the middle there. That's the union. It's the union of those 2 sets. Also, always make sure you put the lowest x or y on the left. So in this case, I know we kind of looked at it starting with the -2, but the -2 is actually the right-hand side of that interval. Okay. All right, now what about doing it from an equation? Okay. Okay, so in some of these, well, you will have a graphing calculator for your exam. So for the exam, you could just graph it. But I do want you to know at least how to find the domain without using a graphing calculator. So looking at part A, I can plug in whatever x value I want. There's no reason why I can't plug in a positive or a negative or 0. So that means that my domain is going to be all real numbers, or negative infinity to infinity. As far as the graph, we can graph, or as far as the range, sorry, the graph is probably going to be the best bet for this. So we go to our y equals here. I'm going to type in 1 minus x squared, and I'm going to graph it, but I'm going to change my window here first because I know it's not going to be a standard window. I'm going to go to zoom 6 to put my graph back to negative 10, 10 all the way around. Okay, now I'm looking at the y value. So this is my highest. Sorry, it's not letting me write on it there, but there's my highest y value, okay? Kind of dragging it across the top there. And then I have everything underneath that. So my y's are going to go from negative infinity all the way up until 1. And 1 is an actual y value on that graph. So my range is going to be from negative infinity to 1, and a bracket there on the 1. Now, same thing on B. I'd like you to know how to do the domain of this without using a calculator. So the idea on this is I cannot plug in a number for x that's going to make the bottom be 0 because I cannot divide by 0. So what is going to give you 0 on the bottom? So a lot of cases you can just look at that and tell that I don't want x minus 5 to be 0. So I solve that by just getting the x by itself. That's my domain. And that means everything but the number 5. Okay, now the range, when you type this one in, you got to be careful. You have to put a parenthesis around that entire bottom because otherwise the calculator doesn't know that you're dividing by the whole thing. If you don't do that, it's going to divide by x, and then it's going to subtract 5 from your answer, which is completely different. Okay, so here's my graph. And this graph doesn't graph the best. What happens is this is a reciprocal function, and you graph this kind of thing, or a rational function. You did this in Algebra 2, and this is one of those graphs that has asymptotes. So what's happening is you have an asymptote right there at 5, which is the place where I couldn't, and again, I apologize, it's not letting me right here, but right here, -5, there is no graph. There's actually an asymptote line right there. And we'll talk more about these graphs later on. You also have one right here, okay? Now, how do you know that? Well, if you look at your table, I need to put my table back to normal here. Okay, so if you look at your table and you look at the y values, okay, first of all, notice that at 5, it says error, which means there's no y value at 5, which is why I can't have 5 in my domain. But now, otherwise, if I look at these y values, I see positives, I see negatives, and as you scroll up here, you'll see that my numbers are getting really close to 0, but they're not going to be 0. Now, at some point, it might say that it's 0, but if you arrow over here to the right, it'll be in scientific notation. It's never going to be 0. So, that being said, my range is going to be -infinity to 0 and 0 to infinity. It's everything but 0. Okay, and again, we're talking about y values. Okay, so let me go back to the graph here again. Y values. I've got y's down here at the bottom. I've got y's up here at the top. I just don't have any y's here in the middle because it's never going to be 0. Okay, the last one. I cannot take the square root of a negative because that's imaginary. So I don't want my underneath here to be negative. I want it to be 0. I can take the square root of 0, or I want it to be positive. So I solve this, and that's my domain. If you want to write it as an interval, that is my domain. Now, if we look at the graph of this, and I'm realizing that I wrote this one down wrong on my paper, let's look at it on the graph here. So we have the square root of x minus 5. Now make sure the x minus 5 is under the radical. If you have an older calculator, make sure that that whole thing is in a parenthesis. Okay, we hit graph. Okay, so we've seen this type of graph already today. The graph starts at 5 and continues on to the right. That was what my domain was. I don't have any negative x's. I don't have any negative y's, but I do have 0 as a y. Now, if you're not sure about that, you can look at your table. Now, these are all the places where I have no graph. But when we scroll down here, you'll see that when I get to 5, it'll say 0. So I do, in fact, have 0 as one of my numbers. So my range is going to be 0 to, not 0, 5 to, nope, I'm sorry. It is 0. I'm looking at the graph and forgetting that I'm looking at the y values. So I have a y value of 0, plus I have all the y's above that. Okay. So domains, I do want you to be able to do those without a graphing calculator, but range, you can use the graphing calculator for that. So just a couple more little things here. So we talked about relations. A relation is just a connection between x's and y's. I'm going to plug this x in and do this stuff to it and end up with a y value. Well, a function is a special relation. This is going to be one where each element in the domain is paired with only one element of the y. So if you have, let's say, an x value of 2, but it goes with 2 different y values, that's not going to be a function. All functions are relations, but not all relations are functions. So how do you tell if something is a function? You can check the ordered pairs to make sure that each input, each x value, only gives you one output, only one y value. Now that can be kind of hard to remember. Is it okay to have 2 y's that are duplicated? Is it okay to have 2 x's that are duplicated? One's okay, one's not. So what I suggest that you do is number 2. Even if they give you a set of points, plot your points and see, do they pass the vertical line test? So the vertical line test, you actually think about drawing a vertical line, sweeping it across your graph. If it touches in more than one spot at a time, it is not a function. So the first one there is good. This one is not good because it touches in two places at one time. So the same thing would happen if they were just a set of points. If you have 2 points that are lined up, that means that it's one x value that's sharing 2 different y values. That is not okay. Now if you have an equation, you can put numbers in for x and see, am I only getting one output from this input? If not, again, it's not a function. If they give you an equation and you've got your graphing calculator, you can also just type it in and graph it, and then again use the vertical line test. So looking at number 4, which of these would be a function? Okay, so looking at the first one there, if I were to actually plot these points, okay, so I'm going to go over 0 up 2, put a dot. I'm going to go over 1 up 2, put a dot. Go over 2 up 1, put a dot. Those are not lined up vertically, so yes, we're a function. Looking at B, okay, I could graph that one, and it graphs something like that. That's going to pass the vertical line test. Now, you might be concerned about the fact that it looks like it's going straight up at the ends, but it is not. But if you use this idea here, put a number in for x and make sure you only get one output. If I put in a number for x and cube it and add 1 to it, I'm only getting one answer. So yes, this is a function. Okay, C, that one is a quadratic. That's kind of something that you should recognize. Okay, if you were going to graph it in your calculator, you would have to solve it for y. So that would be 2y is equal to negative 3x squared plus 5. Y is equal to negative 1.5x squared plus 2.5. Okay, and then you can graph it and see that it's a parabola, but unlike the one up here, it's not a parabola that goes to the right, it's a parabola that goes down. So I don't know what this looks like exactly, but it's going to be something like this in the fact that it's a parabola that goes down. So yeah, this one's good. Now, if you don't have a graphing calculator handy or you're having trouble solving it for y, again, do what it says to do up here for number 3. Put a number in for x. See, do I only get one y value back? Any number that I squared is only going to give me one number. So yeah, we're good there. Okay. Now this last one here has a power on my y. So this is a no-no. Okay. Because if I plug a number in for x and I solve for y, eventually I'm going to have to take a square root. And when you take a square root, remember, there's a positive and a negative answer. So a good rule of thumb here, you cannot have a power on y. And if you do, good chance it's not a function. If you were actually going to graph that one, it looks like an ellipse, which is maybe not something you've talked about. It's like an oval shape. Okay, and that's definitely not going to be a function because it won't pass the vertical line test. Okay. All right, next thing is function notation, and you've seen this before already, but it's in this section, or in this set of sections, so I thought we would cover it. Again, your x's are your domain, your ranges are your y. Y is called the image of x under f, and you denote that by saying f of x. So f of 1 means I'm going to plug 1 in for my x value. So 1 squared plus 2 times 1. 1 plus 2 gives me 3. Okay, next, negative 3 squared plus 2 times negative 3. Whether you do this by hand or in the calculator, please be careful. If you do not put that in a parenthesis, the calculator is going to take negative 3 squared and tell you it's negative 9. It should be 9 plus negative 6. That's going to give you 3. Now the last one here, when I plug this in, I'm going to be plugging in a plus b squared plus 2 times a plus b. That's because my function was this. So every place I see x, I have to put a plus b. Okay, so we're going to multiply this out. Remember, we're not going to just square the a and the b. That's really a plus b times a plus b. So distribute or FOIL, if you know that term. That's going to be a squared plus 2ab plus b squared. Now, I'm doing that in my head. If you need to write that out and do it in more steps, then do that. Distribute the 2a plus 2b, and combine like terms. Now, there's nothing I can combine there, so that's actually my final answer. All right, last part here is composition functions. So this is something, again, that should look familiar from Algebra 2 or from Pre-Cal. So this expression here, f of g of x, is the same thing as f circle g of x, and that's a composition function. In both of these cases, you're plugging the input g of x into f of x. So think of it as just substitution. So in the case, in your book at least, what they're having you do with this is not come up with a composition function, but just do a composition operation of sorts. So right here, I'm doing g of f of negative 2. So I'm going to do f of negative 2. F of negative 2 is 3 times negative 2 minus 2. And when I do the math there, that's going to be negative 8. And so I'm going to take this and I'm going to plug it in right here and do a substitution. And now I'm going to do g of negative 8. So I'm going to take this g equation right there and I'm going to plug negative 8 into it. So that's going to be negative 8 squared is 64. And that is my final answer. The negative 8 just helped me get to the final answer. 64 is my one and only answer. Now on B, this is the same thing as this. You need to be able to recognize these both ways. So this is what I'm going to do first here. I'm going to do g of 3. So, and actually let me do this in red, just so it matches what we did over there. Okay, so g of 3, that's going to be, write this out here, g of 3 is going to be 3 squared, which is 9. So this 9 is going to get plugged in right back there. So I'm going to have f of 9. So that's going to be 3 times 9 minus 2. 27 minus 2 is 25, and 25 is my final answer. So some of these questions are pretty short, just asking you to give domain and range. Again, use your calculator, but at the same time, make sure that you can find domain without a calculator, because there's no reason why you shouldn't be able to. Range, though, is a little bit different. The composition functions, like I said, they're all tested, they're all in your book, just like this. But if they did have you do it with a letter, you do it the same way. It'll be more kind of like what we did up there. But we'll, if it's something that I find out that you're going to have to do it that way, I'll make sure we do some examples before I would potentially assess you on that.